Well, well, what has the cat dragged in today? It's a video tutorial on state machines in Bolt. Now, as we discussed in the previous video, our basic AI is going to be very easily divided up into several states. We are going to have the patrol state, in which the AI just spins around looking for the player. We are going to have the pursue state, in which the AI is pursuing the player. And then we're going to want to have the end game state, where the enemy doesn't chase the player and the enemy doesn't rotate anymore. Because whether the player has reached the chicken or the enemy has caught the player, we don't want the AI to continue to chase or rotate. If the player is running away from the AI and reaches the chicken first, we want the AI to stop. We don't want the AI to continue to chase the player, catch the player, and then have the player confused. It's like, did I win or did I lose? Likewise, if the enemy catches the player, we don't want the enemy to then go straight back to spinning around in place. And as you might be thinking it for the moment, it's like, hold up. I've also got these same problems for the player, don't I? If I reach the chicken, I don't want the player to continue to move or to be able to rotate. And if I'm caught, I shouldn't be able to move or continue to rotate. I don't think I built that into my player controller. Yeah, no, I didn't build that into my player controller. Now, does that mean that our player could also be a state machine? Yes. But we didn't start designing it that way. It doesn't mean that it's impossible to get our player into a state machine, but it does mean that it would be a little bit more work. And really what we are looking for here is a simple true-false variable. Is the game running? True, false. And if the answer is true, well, then we can rotate and we can move. But if it's false, then we can't. Now, both the player and the enemy are going to have to know this information. And when you have a scenario where you have a variable that multiple objects are going to need to access, this is generally speaking a good use of a scene variable. So what I'm going to do is I'm going to come to, in my hierarchy, the scene variables list, and I'm going to add in a new scene variable. I'm going to call it game running. I will set it to a Boolean, and I'll set the default value to true. The game is running. That's its default state. And now it becomes a very simple modification to our player macro to fix this problem. Yes, I know I said we'd be working on the enemy, but we do need to fix our player first. So all I got to do is, again, I'm on the move macro, is I'm going to create a new link here, and I'm basically going to branch. And if that branch is true, continue on with business as usual for moving. And as far as what am I going to branch that off of, I am going to get a variable from the scene. I'm going to get scene variable. And I'm going to type in game running. And then I need to do the same thing for rotate. I'm going to do rotate slightly different because depending on how you have things clicked and selected, you might have noticed something. So when I went to do the get variable for scene here, I had to type this in. There was no autocomplete here. Now watch this. I'm going to select the player, and I'm going to click on Edit Graph for Player Rotate in the inspector. I'm going to do the same thing I did with moves. So I'm going to drag this off into a control branch. I will continue on if it is true. And I will go here to scene. Oh, I have the ability to get game running now. If you have a game object selected in the hierarchy and you edit the macro through the inspector, then Bolt is smart enough to be able to pick up on scene variables and object variables that are currently loaded up. But if you go through it via the asset version, it will not pick up on that information. It's still the same macro, it's just a little bit confusing depending on which one you have selected. Just wanted to point that out because it's inevitable that you're going to notice like, hey, wait a minute, sometimes it's filling in this variable and sometimes it's not. That's why. And anytime we do a refactor, I am always going to want to hit the play button just to make sure, yep, I can still walk, I can still rotate. Excellent, done. Now we can actually get to the AI. So what I'm going to do for this is instead of creating a flow macro, I'm going to create a state macro. So I'm still in my macros folder here, and I'm going to right-click, create, bolt, state macro. And I'm going to call this state macro an enemy AI. I'm going to click on Edit Graph. And it's going to be completely blank, as most macros tend to be. Now, instead of adding in units, which you'll notice that I can't actually add in units, what I need to do is I need to create a flow state. I'm also going to switch to full screen to make sure we can see all of our options. Now, the first state that we create is going to be our starting state. This is a state machine. We can only ever be in one state at a time, and we must be in a state at all times. So the very first state that we create, that's our default state that we are going to start in. And actually, I am going to rename this to the patrol state. I know that I am also going to need a chase or a pursue state. So I'm going to right-click, create flow state, which I shall call chase. I also know that I am going to need a state called endgame. So I'm going to create another flow state titled endgame. Now, each of these states are basically their own flow graphs. If I double-click on patrol, I will enter it in, and now I'm in familiar territory. This is a flow graph. I can do everything that I have always done inside of a flow graph. Now, I do have two special events, on enter and on exit, which are common for state logic. And we will use the on enter for a couple of these. But for the rotate state, or the patrol state, I should say, nothing much is going to be going on here. All I need to know is what is my rotate speed, and rotate based on that speed. That's it. That's all I'm doing here. So off of update, I'm going to drag out a wire. And I am going to say transform dot rotate axis angle. Just like we did for the player. What axis am I rotating around? Transform dot up. Since it is convenient to not use a magic number here. Actually, I'm going to get rid of those two. Don't need those for this state. And then the angle that I'm going to rotate around is going to be my rotate speed. Again, this is something I'm going to want to be visible in the inspector. So this will be an object variable. So I am going to not drag a wire off of there. I need to get my rotate speed. So I'm going to go to variables, object, get object variable, rotate speed. I am going to multiply. I'm going to use the scalar version since I know I'm using scalar values here. I'm going to multiply that rotate speed by time.delta time, as always, to make sure that I am doing this in terms of degrees per second. And then I will feed that into my angle value. Given that that is a functional piece of code, I should be able to test this. And I just remembered that this is going to fail for two reasons. One, I just get a little bit too excited about testing code. It would actually help to add the state machine onto the game object in question. So I'm going to go to add component, bolt, and I'm going to add a state machine on. Not a flow machine, a state machine, to which I can drag in my macro. I am also going to need to put in my rotate speed variable. I'm going to set it to a float and set it to 90 degrees. Now I can test it. Yep, I saw it. Yes, he is rotating. And I can immediately see that I do need to adjust him a little bit because I want that cone of vision to be slicing more through this wall to test that particular aspect of the code. So I am going to grab him and move him closer. Let's rotate. There we go. That should make it so that it's very clear. Yep, very easily and clearly hits the player. And I'm still close enough to this wall. Yes, I am. Very clearly, easily hits the player. Excellent. So I am prepared for that portion of testing. Let's head back to our state machines. So we have our patrol state set up. Now, how do I get to the chase state? We do that through a transition. So if I right-click on patrol, one of my options is to make transition. Selecting that gives me a wire that I can then point to any other state. Of course, I want to point towards the chase state right now. And upon doing this, I get this little setup. I have a wire going from patrol to this little weird icon here, and then a wire going from that to the actual chase state. This is also a flow graph. Everything's a flow graph in Bolt in the end. And if I double click on this, you will notice it comes pre-populated with a single block, a trigger transition. How this works is that whatever information I put in here, if I have a wire that connects into this trigger transition block, that will trigger the transition. So, an easy way of demonstrating this is to put in an on-trigger enter event. Why am I using onTrigger? Well, the vision cone's a trigger, right? I want to know when the player enters the vision cone, which means when it enters that trigger. Therefore, an onTrigger enter event. And I can't just immediately draw the wire over because the AI will freeze. So rather what I'm going to do is I'm going to ask the question, okay, on trigger enter, did I see the player? And if I saw the player, I'm just going to trigger the transition. There's still a lot more that we have to do, but this will be a nice proof of concept. So I'm going to branch off of here, and I'm going to say compare tag. And then off of compare tag, I will branch. And if that is true, then I will trigger my transition. What tag am I comparing? Well, I am going to take the collider's tag, the collider, which is going to be the player. I'm going to see if it has the tag player. That's a good question. Is my player tag just player? No, it's not. This is a very, 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 very common source of errors in Unity is when you're relying on something to be tagged and it's not actually tagged as that thing. So anytime you run into oddities and you're dealing with tags, one of the first checkpoints that you should use in debugging that is checking to make sure that everything is actually tagged the way it's supposed to be. And then the second thing you check is for typos, because capital P player is a different tag from lowercase p player. So I'll make sure I set that tag on my player object to player. And now what I expect to see is the moment that vision cone hits the player, it should stop, because I triggered a transition into the chase state, and the chase state doesn't have any logic. Doink. That is precisely what I wanted to see. And if I wanted to see that actually in action, I'll take maximize on play off. I'll move my flow graph down here so we can actually see it. Make sure that I have my enemy selected. Hit the play button. We can see by the blue coloration that it's in the patrol state. Hit. We can see the pulse go through, and now we are in the chase state. So that is how, at its core, the state machines work in Bolt. Now, we got to do a little bit more logic than what we got here, because we don't actually want to be able to detect the player through a wall. That's not what we want to have happen. So we're going to have to fix a few things. The first part of our logic is actually fine. I'm just going to break this link here to the trigger transition and get that out of the way. I have entered an object. We do have an on trigger enter. That could be the wall, by the way. So that's why we have to compare the tag to determine, well, is the thing that just entered our trigger volume the player? And then if that is true, what we need to do is a Raycast. This is a very common action in game development where you take a point of origin and a direction and basically draw a line out and ask the question, does this line hit anything? That is a Raycast. And Raycasts are all under the physics class. So physics.raycast is how you access the Raycast information. Now, there's a lot of different versions of Raycast. As you can see, there's lots and lots of information that we can do here. The version that we are going to use is going to be this last one, where we pass in a ray, and we also get hit information out of it. So we want the Raycast version that has ray and hit info. The ray is how we will determine where we're looking, and the hit info is what we actually need. Now, how are we going to calculate out our ray? Well, if we drag off of here, you can see that, so I'm dragging off of the ray input. I can create a new ray. A ray is composed of an origin and a direction. An origin is our starting point. Where is our starting point? If we use the position of our character, that's going to cause us problems. We don't want to do that. Rather, I am going to want to define a specific point that my rays emit from. So what I'm going to do is, as soon as I remember the fact that I have this in full screen mode, so I'm going to come over to my enemy, and I'm going to figure out, like, where do I want this ray emitting from? So I am going to create an empty game object as a child. I'm going to call it ray origin. I'm going to try to figure out where precisely do I want this. Now, I'm going to want to make sure that this ray is actually inside the trigger volumes. The position of this ray is very important. So, like, if I have this ray back over here, and I don't want global, I want local, thank you very much, to avoid confusion. Now, if I have the ray origin point back here, it's going to hit the character model, and that's not what I want. So I want to make sure that the ray is a little bit forward, that it is inside my detect box, and it is inside my vision box. That avoids any chance of the poor thing getting confused and detecting the wrong thing. Now, how high up do you want the ray is going to sort of depend on where you want to be looking. Now, do you want to raycast from the stomach? Do you want to raycast, like, literally from the eyes? It really doesn't matter too much, just as long as you are conscious of that decision. Again, you don't want to put it up too high. So, like, if I had my raycast up here, unless I also was equivalently looking, like, over the top of the head of the player, fair good odds that I'm going to impact in on this cube. So wherever I put this, I do want to make sure that it's within both of these cubes just to avoid any complications. So I am going to, in fact, put my raycast origin sort of at the stomach level here at 1. And then I will... Oops, actually, no, not at 1. 1.25. Because I want to make sure that it starts inside these boxes. And then I will also make sure that that's where I am looking at in terms of the player. Now, how do I know what this location is? Oh, that sounds like a good candidate for a object level variable. So I'm going to go to the enemy here. I am going to go to my variables. And I'm going to create a ray origin variable. And I'm going to define this as a vector. Well, it would be nice if I could define it as a vector 3. Keep forgetting that Bolt does not like you doing this. But as you notice here, there's no way for me to actually drag in my empty game object. So I do have to set up my ray origin as a game object. So that way I can link that up. So that way, if I adjust my ray origin, I don't have to do any fiddling with my variables. Going back into my flow graph here, I can now grab my origin, which is going to be variables, object, and because I have my enemy selected, I can do it the lazy way and say get ray origin. And notice it is smart enough to be able to know that, okay, I might be feeding in a game object, but it's smart enough to actually get the position out of it. I don't necessarily like that. I just wanted to point it out. It can do it, but I'm sorry. I just like being needlessly verbose. It is the programmer in me. I like to explicitly state that I am getting the transform.position out of this game object and feeding that into the origin. I think this is a much better way of doing it, of being very explicit like this. Now, what is the direction? In other words, where is this ray looking? I know where it starts. Where is it going? And for this, we have to do a little bit of matrix, or not matrix, vector math. So I already know that I'm going to come in here to the vector 3 and do a subtract. And again, I realize I probably just did that a little bit too fast, so I did a right-click, add unit. I went down to math. I chose the vector 3 category, and then I chose subtract. Because if I've got vectors A and vectors B, A minus B returns to me the vector that points from B to A. So if I want to point from the enemy to the player, the enemy position... Oops, let me switch back to full screen here so I have some more real estate. So if it's from the enemy to the player, the enemy value has to be the B. So I'm looking, it's always from B to A is what A minus B gets you. And then the A is going to be the player's location. How do I know that? Oh, that would be the collider information that we have over here. So off of this, I could do a transform.getPosition. Now, this is going to be at the player's feet. That is something we have to keep in mind. This is going to be at the player's feet. So I probably want to add an offset to this. And just to make things a little bit simpler, and because we are getting a little bit long on this video, I am going to do a tiny bit of a hack here. I'm going to say, okay, I'm going to offset this by 1.25, which was the same value that I had for my own Raycast origin. So I'm going to take that value, and I'm going to use add. And I'm just going to add the literal 1.25 to the y value. And then finally, I'm going to feed that into subtract. And then I can feed that into direction. Clean up my positioning here just a tiny bit. Okay, so I've compared my tag. It is the player. So now I'm doing a Raycast. Where is the Raycast? I'm grabbing the Ray origin, the position of that game object, and I am grabbing the position with 1.25 added onto it of the player, which is what's going to be coming out of the collider. Subtracting those to get a vector pointing from the Ray origin to the player. Feed that into direction. Feed that ray into the Raycast, and now I can once again ask the question, is this the player? So once again, I am going to compare tag. I am going to want off of this Raycast hit. I am going to want to get the game object off of it. Because notice it will not directly hook into there. And as I temporarily space out on exactly what it is. Oh, right, collider. Because the collider can be fed into there. So I just had a momentary blank out there. You can't directly access the game object from hit info, at least not in Bolt. I can do that in C#. Thank you very much. They're using dot accessors. But yeah, so I take the hit info. I get the collider information out of that hit info, which that in turn can be fed into this game object slot here, automatically grabbing the game object out of it. And of course, once again, I am looking for the player tag. And branch off of that. And if that is true, trigger a transition. Wow, is that a mouthful? None of these particular steps is complicated on their own. It's just you've got to make sure they're chained together in the right sequence. So let's make sure that they are, in fact, chained together in the right sequence. So what should happen is, well, we actually won't be able to tell too much, but the player, the enemy, should be able to rotate and scan without anything happening. And then it shouldn't stop through the wall. But if I come out and make myself visible, it stops. Because now I have been successfully detected. That is what you should see. Again, to run through the tests, nothing should happen when the vision cone passes through the wall. Nothing should happen if the wall is between me and the enemy and the vision cone touches the player. And then if there is a clean line of sight, including over our little obstacle here, the enemy should stop rotating. If something here is not working, here are the areas to check. First, check to make sure that your player is, in fact, tagged as player. Not the game object name. That's not what we're asking. The tag property has to be player, which is one of the default tags that Unity provides us. For the graph information, again, that's going to be in the transition point here. make sure that your two compare tag actions have player typed in correctly. Make sure that your ray origin is properly placed on the player. And again, properly placed being defined here as not possible for it to hit the outside of any of your vision or detection boxes. So here I have my ray origin inside my vision and inside my detect boxes. And it is outside of my player. So make sure that it's positioned in such a way that when the ray starts from this point, it's not going to hit any of your enemy-related stuff. Make sure that this ray origin has been entered in as a game object and that you've properly linked up the value. And then make sure that when you get the player's position, which is off of the collider on the on-trigger enter, that you add something at least, because otherwise you're going to be raycasting straight down towards the player's feet, and that might also cause issues. It is much better for you to be raycasting towards the player's chest, which is why I'm adding the 1.25 here. And given the length of this video, we will approach the logic involved of making the AI actually pursue the player in the next video. And with that, as always, if you enjoyed this video or you think you learned something new and interesting from it, a like would be very much appreciated. And if you didn't, well, the dislike button is right next to it. Until next time.